Hi everyone, welcome to my channel, and in this video we are going to discuss a problem known as maximum subarray from Leetcode. In this problem we are given an array and we have to find its subarray such that the sum of the elements of this subarray is greatest and is greater than all the subarrays that exist in the array. Now before we proceed to solve the problem, let's first understand what is a subarray. Let's say our array is 1, 2, 3, 4, 5 and 6, and the subarray of this array is a part of this array, and it should have elements common to this array, and it should be contiguous. That means the order of the elements in of the subarray should be same as the order of the elements in the original array, and no element should be skipped in the subarray which is belonging to the original array in a particular range. Let's say our range is of the subarray is from original array's index I equal to 1 to I equals to 3. Then the subarray becomes 2, 3, 4. Similarly, we can say 1, 2, 3, 4 is also a subarray of this array, and we can also say 2, 3, 4, 5, 6 is also a subarray of this array. But there is one more thing, that we cannot say that 1, 3, 5, 6 is a subarray of the array, because it is skipping 2 and 4 in between, and the order might be same, and the elements are also belonging to the original array, but since we cannot skip the elements that are lying in a particular range for which the subarray we have chosen. For example, here the range we have chosen is I equal to 0 till I equal to 5. We cannot skip the elements in between. Similarly, if we have chosen a range from I equal to 1 to I equal to 5, we have to write all the elements from 2 to 6. We cannot skip in between. Now coming back to the main problem, after we have understood what a subarray is, we have been given in the array, and we have to find the subarray which has the largest sum compared to all other subarrays. Now we don't actually need to find the subarray, but we have to find the sum of that subarray which has the largest sum. Now we have been also given some constants, that the length of the array should be less than equal to 10 to the power 5, and the maximum range of the element that the array can contain is still 10 to the power 4. Now let's try to first find a basic solution for the problem so that we can come upon an answer. So the very first thing when we try to approach this problem with a very basic thought is that we would just, let's say our array was 1, 2, 3, 4, 5, 6. We would first keep an index I starting from the very first element from the array, that is I equals to 0, and then we would keep just a index j that starts from the next index from I. Let's say that is equal to I plus 1, that is equals to 1, and for each I and j we would keep a range of elements between I and j, including the element of the index I and index j, and we would find the subarray of this. Find the subarray using this by traversing I from 0 to 5 and j from 0 to 5. We would traverse j from j from I plus 1 to 5. We would traverse j for each I. Now let me demonstrate to you how we are going to do this. Let's say our array was 1, 2, 3, 4, 5, 6, and our I was 0 and j was 1. So for I equals to 0 and j equals to 1, our subarray is 1, 2. For j equals to 2 and I equals to 0, our subarray is 1, 2, 3. For j equals to 3 and I equals to 0, our subarray is 1, 2, 3, 4. Similarly, for j equals to 5 and I equals to 0, our subarray is 1, 2, 3, 4, 5 and 6. Now coming back, when j ends we should increment I to the next position, that is equal to I equal to 1. So for I equals to 1, let me just copy it. Yeah, just yeah. For I equals to 1 and j equals to also 1, we would just have a subarray of 2 only, and for I equals to 1 and j equals to 2, we would have a subarray of 2 comma 3. For I equals to 1 and j equals to 3, we would have a subarray of 2 comma 3 comma 4. Similarly, when this ends, that means we reach to the end 2 3 4 5 6, j reaches 5, we would again increment I to 2. And this case, once we again copy this, we copied this. Now we should place it here. Now for I equals to 2 and j equals to 2, our subarray is 3. For I equals to 2 and j equals to 3, our subarray is 3 comma 4. And for I equals to 2 and j equals to 4, our subarray is 3 comma 4 comma 5. Now doing this makes us reach doing this makes us reach all the subarrays. Now once we proceed to further do like this, we would get all the subarrays. Now there is one problem with our approach, that we start j from 1, but we should have started it from I only, because if we don't start it from I, we would actually miss one subarray, that is 1. We are missing for the first time. So once we have understood how to go with this approach, now let's move forward to the code. But just one thing here to notice, j would not start from I plus 1. Instead, j would start from I only. J would start from I only, and it would traverse till the end of the array. Now let's move on to the code. What we would do is we would keep an I, like we said in our approach, that would go till the length of the array nums. We would also keep an j that would go from the length of from I till the length of the array. And we would also keep a variable k that would make it sure that we are going from the range I until j. So this would help us to go from I till j. And now once we have just made these 3 loops, now these would facilitate us to find all the subarrays of our array. But before we could do that, we don't need to actually find the subarray of our array. We just need to find the sum of our subarrays and get the maximum sum out of all the subarrays into max sum. Now we would have to keep not the maximum value of, we have to keep maximum value not to 0 but to less than the constant that is given here, minus 10 to the power 4, because what if all the numbers in the array are negative? For in that case, if we try to just return maximum, it would return 0, because when it would compare maximum with the sum, it would never be, the sum would never be greater than maximum, but 0 won't be the answer of our array if all the elements are negative. For in that case, we would have to keep the value of maximum less than the constant. Let's say we keep it minus 1 lakh. We keep it minus 1 lakh, the value of maxim. For that we just have to typecast it. Yeah, we have kept the value of maximum minus 1 lakh because of constant that we have been given the minimum value of our array's element is minus 10,000. Now once we have done that, after the loop of I and j, we would have to keep a variable sum. Why sum here? Because for each I and j we are getting a subarray. So for each subarray there should be a different sum, and so that's why we were declaring the sum after just j. So and after that we use k to calculate the sum of that particular subarray that we are getting for I and j. Now once we have calculated the sum, we would give maximum the value of the maximum value between sum and maximum after every loop of I and j, and after this we would return maximum. Now let's see if we have done anything wrong in our code. I don't think so that we have done anything wrong because everything seems to be fine. Yeah, everything seems to be fine. Now let's just execute it. Okay, something wrong. Yeah, a is not a variable, nums is our variable. Maximum equals to, oh, the spelling of m is wrong. Let's just we have done just one more thing wrong. Instead of doing j++ here, we have done I++. So we would run the code now. I think so that it would run fine now. Yeah, we are getting the expected output for this. The expected output for this was, according to our test case, that 6 is the maximum sum of this subarray that has the maximum sum compared to other subarrays. Now let's try this test case. Yeah, this is also working fine. So another sample test case would make it sure that our code is working fine. Yeah, it is also working fine. Now let's submit our code. Yeah, we see that we have just exceeded the time limit. Let's see how many test cases we pass. We have passed 200 test cases, but 9 test cases failed because we exceeded the time limit. Now, why we exceeded our time limit of our code? Why it exceeded our time limit? For the reason is that the time complexity of our code is of n cube. Why it is of n cube? Because once we first we traverse I from 0 to till the length of nums, then we also traverse from I from 0 till length of nums, then we again traverse k from I till j. Now the worst case is when I is also traveling from 0 to nums dot length, and 0 and j is also traveling from 0 to nums dot length, and k is also traveling from from I till j. Now a case when j is at nums length and I is at 0, then k is also traveling from 0 to nums length. That makes our code run for 3 traverse the length of the array 3 times, so making it have a complexity of n cube. So we are seeing that our code is quite complex and it is not good when it comes to time complexity of it. So how you would reduce the time complexity of our code? What is a better approach to solve this problem? let's come to that now. How you solve this problem with a better approach? Let's see. Now let's say our array is 1 2 3 4 5 6. We would keep another array which would keep the sum till the ith index of the array. Let's say the another array keeps the sum of till 0th index at 0. So it would keep at 0 index 1. At first index it would keep the sum till first index all the elements. So it would keep 3. Similarly for 3 it would similarly for third element it would keep 1 plus 2 3 6, then 10, then 15, then 21. It stores the sum of all the elements till the ith index at the ith index only. Now after we have done that, now we would see that the largest sum, if the element or the all the elements are positive, we would get it as the last element. But this is a very obvious case and easy case, and we would not go with that because in our array there are negative elements too. This is just to demonstrate what we are going to do in the question. Now we would do the same only, we would keep another array, but let's take a different test case. Let's take this test case. Now it is -2, -1, -3, 4, -1, 2, 1, -5, 4. Now for this test case, the sum at 0th index is -2, and we would compare this value with, we would also keep another variable called maximum, and we would compare this value with maximum and update the value of maximum. And now the sum till this element is -1, but -1 is less than 1, so the sum of our subarray -2, 1 is less than 1. That means we have to discard this subarray because it isn't of any use to us, because already we have an element from which if we would start the subarray, you would have a greater the sum than starting from -2. So we would start the subarray from 1. We would not actually start the subarray from 1. We would just update the sum or be the sum at that index to 1 instead of -1. Now once we have updated -1 to 1, we will calculate the sum of the second index, that would become -2. Now -2 is greater than -3, so we have no problem. Now we would add 4 also, so that would give us 2. Now 2 is less than 4, so the subarray 1, -3, 4 doesn't really help us getting the maximum sum because there is already an element 4. From if we start the subarray from 4, we would get a greater sum than if we would have started from the subarray 1, -3, 4. So we would update the subarray from 4. Now we would not actually update the subarray, but we would just update the sum at that index to 4. Now coming back to -1, 4 plus -1 equals to 3, 3 is greater than -1, 3 plus 2 equals 5, and 5 plus 1 equals 6. Now at each of these steps, whether we are replacing the sum at that index or not, you would update the maximum's value by comparing with these sums. You would compare maximum's values to these sums, and we would update maximum's value. Now once we have done that, now here the sum was 6 till here, and 6 is also greater than 1. 6 plus -5 is 1, 1 is greater than -5, 1 plus 4 is 5, and 5 is also greater than 4. So if we compare each of the sum elements with our maximum, we would get that the maximum sum is 6, and that is actually the answer of our problem. Now let's take one more test case to make things more clear. Let's say our original array was 54178, and the sum array is getting 5. 5 is greater than equal to 5, so it's okay to move forward. 9 is greater than equal to 4, 8 is also greater than equal to -1, say 15 is also greater than equal to 7, and 23 is also greater than equal to 8. So the maximum that we are getting without replacing any of the sums value is 23, and that is also the correct answer. Now how we would implement this approach? Now first of all, we would create both of these arrays, our original array and B, as one indexed arrays, because doing these things with one indexed arrays is more pretty easier than doing with zero indexed arrays. It can be done with zero indexed arrays too, but I'm just more comfortable with one indexed arrays. So how do you convert a normal array to one indexed? Just make another array, let's say C, which has a size greater than just one greater than the original array, and store from one index till n, and where n represents the size of the original array, because n would now be an index in C. N would now be an index in C. So now store all the values of A to C. Now how you would do this? That since the indexes of C is one greater than the indexes of the original array A, we would just do C of I is equal to A of I minus 1 for I equals to 1 till n, where n is was the size of our original array. So, and we would create B also like this. Now once you have understood how we would approach the problem, now let's move on to the code to implement it. Here we would just clear it all and just move forward. First, we would create a new array A, which would have a size just 1 greater than nums. And we would also create a array B, which would store the sum values at till the particular index I, and we would give the size of B as same as the size of A. Now once we have done that, now we have to also copy the values of nums to A. So from int I equals to 0 till nums dot A dot length, because here we would need A's length, as A's length is greater than nums, we would do AI equals to, not from 0, since we are having a one index, we are trying to have one index array, we would start from I equals to 1. AI we would do equals to nums I minus 1. How this would work is, let's say our original array was 1 2 3 4 5 6, its indexes were 0 1 2 3 4 5 5. Now we want to convert it into same array 1 2 3 4 5 6, but now we want the indexes also to be 1 2 3 4 5 6 0 1 2 3 4 5 6. So to copy to these indices, you would just need to copy the elements which are present in one less indices. For first index of B, you have to copy the element present at 0 index of A. For second index of B, we have to copy the element present at first index of A. For third index of B, we have to copy the element present at second index of A. That's how we would proceed till the end. For sixth, we have to copy the fifth element present at fifth index of A. That's why we are doing AI is equal to nums I minus 1. Now for calculating B, for int I equals to 0, we also now need to keep the maximum variable. Int maximum equals to 0, not 0 like previously we took, since keeping in mind the constants that we are given. maximum will be equal to minus 1 lakh. Now from I equals to 1 till I is equals to b dot a dot length I plus plus, we would give bi the value of bi is equals to ai plus bi minus 1. Now how this statement would work? Let's say our array is new one indexed array is 0 1 2 3 4 5 6, because the element at 0 index in the new one index array is 0. Now bi is currently 0 0 0 0 0 0 0. So when we do b1 is equals to a of 1 plus b of 0, according to our equation, it gives b1 the value of, sorry, okay, it is hanging a little bit. It gives b1 the value of 1. Now when we do b2 is equals to a of 2 plus b of 1. Now what were, since b of 1 is now 1, we would replace 0 with 1. Now when we do a2 plus b1 for finding the second element at the second index, we would get 2 plus 1, that equals to 3, and that is actually the sum of 1 and 2. Similarly, b of 3 is equals to a of 3 plus b of 2. We replace first this with 3. Now 3 plus 3 equals to 6, which is actually the value of the sum 1 plus 2 plus 3. And in this way you would get the array of sums of till the particular ith index in B. Now once we have done that, if now our condition was that if this bi, if the sum till a particular index is less than the element ai, we need to replace it with, we need to replace the bi with ai, because we want a subarray which gives us the greater sum, not a lesser sum. So if bi is less than ai, we would simply replace with it with ai. Now we would just give maximum a value of the value of maximum value between sum, sorry, it's not sum, bi and maximum. Now we are updating the value of maximum at each index with the value of bi. Whenever we get a greater value of bi than maximum, this statement what it does is, if the value of bi is greater than maximum, it updates maximum with bi as it keeps the value of maximum. Now why we are doing this, I already explained you that whenever we are finding the sum till ith index for the array, we are updating the value of maximum in that array, in that sum array that we are taken, that is B. Now let's see if our code is right. Yeah, it is, it seems fine for each array, for each, yeah, for each line it seems fine to me. Now let's just run it if it is giving right answer. Yeah, it is giving right answer. Let's just run these two also cases. Yeah, this is also working fine. By God's grace. Yeah, this is also working fine. Now let's just submit it. Yeah, our code got submitted, and it took a time 4 milliseconds. And although it is showing that it is faster than 8.63%, but our approach is actually one of the fastest approach that I have taken for solving this problem. So this was the solution. I hope it helped you. And if it helped you in any way, just make sure to like and comment on the video, and just subscribe to my channel as it provides support and motivation to upload such kind of videos. And till then, goodbye.